All right. Well, let's start with some intros, so get kind of acquainted with who's up here on the panel. So starting with Horace, my old colleague, PyTorch. So three things about Horace. One, he's a core contributor still of PyTorch, although it says at Meta here. That's strange. But actually now at Thinking Machines. He's also an ML systems researcher with papers at OOPSLA, Eichler, and kind of like the who's who of conferences, including NeurIPS. He's also a competitive coder and open source contributor. And yeah, kind of, I guess you reached the ICPC World Finals. Yeah. That's pretty cool. Awesome. Welcome, Horace.
Thank you.
All right. And then I have Dhruv. So Dhruv, also a former researcher in FAIR. So kind of embodied AI pioneer and tech leader, formerly led FAIR's embodied AI work including Habitat. He's also an award-winning educator and academic out of Georgia Tech, actually where your wife is also a professor there, so power couple for sure. Well-cited. And then obviously a huge advocate of multimodal AI over the years. And that makes sense given your work in embodied AI. Awesome, welcome. And then to his left is Candido, so another ex-colleague of mine, co-founder and CTO of Evolutionary Scale AI, focused on AI and biology, one of my favorite areas that I think AI can have a really positive impact in. Let's see, he was formerly at Google X, working on the Loon project as CTO of that. Has researched multi-scale, geospatial, and sustainable AI, with lots of papers, including a seminal paper on scale, masked autoencoder at ICCV 2023, and actually also works on AI for biological sequence modeling, as I mentioned. So welcome, Sal. Awesome. And then to his left is Eugen Hotaj, member of technical staff at Perplexity, worked on Llama post-training. And so he's a ML engineer, formerly Google also, at Perplexity, worked on open source, including, wow, you worked on GPT-2? That's cool.
Not that GPT-2.
Okay. You worked on style transfer and a bunch of other stuff. And you also worked on adaptive neural architecture search in the past. Awesome. Welcome again. And last but certainly not least, Carina Hong, founder and CEO of Axiom, former Stanford PhD, a Rhodes Scholar. Let's see, award-winning mathematical researcher. And man, what else could you do? I know, right? I got a crazy panel here. If I can get my paper here. Let's see, and a community builder and student leader. Wow, so you actually led MIT's undergrad math association, recipient of Mathematics Community Building Awards, NSF awards. Wow, okay, so crazy. So from MIT to Stanford PhD, founder, raised money, building a team and a company. Amazing. Thank you. Welcome. Awesome. Actually, so fun fact, all those bios were actually generated by ChatGPT. So I'm kind of curious, actually, like, did ChatGPT hallucinate at all? Was it accurate? Was there anything, actually, Eugen, I know it said that you're still at Meta, which is like maybe wishful thinking for me, but like, I don't know.
Yeah, big news. I'm at Perplexity now.
Yeah.
But yeah, besides that, everything else sounded pretty reasonable.
Okay.
I think also, like it said, I was at DeepMind, which I was at like Google Research, but I guess small mix-up.
Okay, cool.
Yeah.
Any other hallucinations? Everything accurate?
It said is for a few of us, right? Like,
yeah.
Which is wrong.
Right.
I'm mostly curious, did you feed it our bios, or is this from parameters?
So it's probably got some knowledge cut off, and I'm sure it did some like, indexing and that, but I fed it, I literally asked it your name and like, give me 3 lines about you all, and it fed pretty good information. I did play with the Yutori API, by the way, and it's actually even better. So, shameless plug for Drew's startup.
I feel like I got it right, but it was like an interesting choice on like what it like picked out, like the 3 things. Like,
yeah.
It was probably like this guy gets a mention for a vision transformer. Like,
yeah.
but yeah. I did do. I was part of that. So
yeah. Okay.
I do agree, like the factual statements were right, but like the emphasis were like a little bit strange. Like I'm kind of surprised that went back to like my undergrad. A little bit surprised didn't bring up like high school clubs and stuff like this.
Okay. Interesting. Okay.
Yeah.
I mean, AI is it's still a work in progress. We're not there yet. So amazing. Okay. All right. So let's kick off some actual questions here. I guess the first one's for Horace, and then I want others obviously to jump in. So, I mean, you and I have been building open source tools for a long time. We worked on PyTorch together. I was like literally surfing through like GitHub the other day, looking at awesome lists on agentic frameworks. I saw one of them had 93 frameworks. Like a bunch of them were like vertically centric, like build an AI agent for like legal or I don't know, whatever it was. But like 93, like what the hell's happening here? Like, we've seen, you and I have seen like the framework wars happen with PyTorch and TensorFlow and all of that. Like, what is the best one you've tried and what do you think that the winner is? Or do you think like we're in for this like crazy entropy for a couple of years and then stuff settles out? Or where do you see this going?
Yeah, for sure. I think definitely like when you kind of see these like framework fights happen, definitely at the beginning there's always like a Cambrian explosion, especially when like the barrier to entry is so low, like it is here, like where like fundamentally an agent framework is just like a string templating library of some kind, and like anybody can write a string templating library. And so like yeah, I definitely think you're going to see like a huge explosion like soon, like right now, and then eventually it'll start consolidating. But I think to me, like the more interesting question about like the agent frameworks is kind of not even about like which one will win. It's kind of more about like what is even the place for agent frameworks in the long run? Because I think one of the things you kind of see, right, with the labs and stuff like this is like things like deep research. They're kind of very much focused on like end-to-end RL trained like agentic tasks. And it's kind of not super clear like how these like plug into like the existing agentic frameworks. Like as in like our agentic framework kind of like going down the wrong path, and they should be focused instead on like building RL environments. Like definitely like even if you're doing RL, there's like a lot of nuances in like prompting and like this kind of stuff. But I think it's not super clear to me like where the boundary ends for like post-training and where it should start for agentic frameworks. And I think my personal suspicion is kind of that we're gonna start seeing like more and more stuff get like swallowed up a little bit by like post-training as opposed to like purely being done in the agentic. That's kind of
I mean, if you go to like local llama, you'll just see like so many like 4-letter word like descriptions of LangChain and just like this. I mean, basically like it's a DAG control flow, like give me components and orchestrate them in Python and all that. And people are like definitely like looking for something better. But my feeling is definitely that the models, once they start reasoning much better, like you'll less need an actual framework at that point. You'll need stuff, but the model itself, in theory, should like be able to reason about which tools to use, like which files to touch if it's doing a coding task or whatever. So anyone else like have a feeling on that, or a framework they love or hate? Preferably hate.
I don't know. I feel like one of the big problems is that the best thing kind of to do, like not even like a framework, but like the best thing that you want to do if you're just doing like an agent-based system is different than what you want to do if you're generating data for post-training and then, trying to change the model through that. And ideally, we would want to be in a situation where you can start from an agentic flow and then you can improve the model doing that. But I just don't see like there's a really good solution yet to doing that whole piece. So hopefully soon it will save us all a lot of code, I think.
Right. So all these kind of like have hopefully like planned obsolescence. Like they're all just going to die in like 2 years and like RL will take over.
I think we do have to sympathize a bit with the framework makers.
Yeah.
The reason why so many frameworks aren't useful is because the ground is shifting underneath them. Like,
that's fair.
When you make a framework, you kind of are playing this balance of having some opinions, otherwise you're not providing any value, but providing enough modularity that people can build what they want to build. And you folks with PyTorch have had to get those decisions right. The history of PyTorch is that it came from a pull, right? Like researchers were already hacking away on Torch, and you wanted to improve that process while not limiting anybody's scope. today you build an agentic framework, and if you misjudge where the capabilities are going to be, you end up putting walls that are just getting in the way of developers trying to get things done. And it's much easier for them to just go directly to the model, and your framework doesn't provide anything additional. So
I had this chat with Jan Stojka earlier today. We did like this podcast, and we were talking about abstractions, and I think like that's like you just nailed it. I mean, I think like if you pick the wrong abstraction, then it's a dead end, right? You can't either hit like the right target user, or like people want to click down to a lower level, or and so like I think like we are kind of building hopefully at like a level where we understand the patterns or things start to emerge, and then you kind of build from there. But like I feel like there's plenty of frameworks that have kind of started all the way at the top, and they're losing, right? They're just like, because all of a sudden I want to have more flexibility and I don't have that, and that's like the framework, that's the gaming frameworks, right? So.
Yeah, I'll give another argument, which is like I think one way to think about it is like, what is the point of like agentic framework in the first place? It's like the reason for agentic framework to exist is that the base model cannot immediately like do it by itself, or like it's like not capable of like doing all the actions, or like like doing its memory, or like handling all the things by itself. And so in some sense, like what you're asking from an agentic framework is you're trying to like get the model to do something that it does not like immediately like naturally do by itself. And if you want to do this, I think in many cases, like I'd say like RL seems like a more principled way to like elicit like a different behavior, as opposed to kind of purely something that's like agentic on top.
Okay, so I keep hearing RL. Everyone is of course talking about RL these days. Like I remember I was sitting in a room with Gary Marcus like probably 11 years ago, and he was pitching us, like he had geometric intelligence. I think Uber ended up buying them. And he had this crazy cast. He had Zubin, right? He had like Jeff Kloon. He had this like amazing set of researchers. And they had literally just formed the company, and all of a sudden they wanted to sell, right? And half the people were like half-time at the company. And they showed us a demo, and it was like, I think it was like Pong or something, right? And it showed like the really smooth actions, like, and then they compared it to like DQN. And we're like, okay, that's kind of cool. But that was like what was exciting at that time about RL. And we kind of walked away like laughing, like this great researchers, but what did they just pitch us? And they wanted, by the way, like 8 figures per employee to buy them, right? Something crazy at the time. But like
that seems low now.
I know. I know. I need one of those 9-figure offers. Yeah, let's put that aside for a second. But like, Dhruv, tell me, like, is RL for real this time? I know we had RLHF, and RLHF is largely a kind of a fake RL. But is this really the future, or is there going to be like something beyond RL, or?
So, predicting the future aside, which is hard, but I think maybe a short history lesson is in order, because people think RL got invented with RLHF, and that certainly is not the case. Like, there's a wonderful talk called, in the beginning, all learning was reinforcement learning. The idea, the genesis of AI was with intelligent agents that can go interact with an environment and, have sensory action loops and exhibit intelligent behavior. And when you start from that abstraction, you kind of very quickly get forced to deal with the dynamic nature of the data that's coming to you, stochasticity of the feedback, long horizon problems, and RL tackled that head on. We actually did see successes of RL 90s with game playing agents, and 2015 is the phase right after the Go results, which were shocking the world. So what did they get right? They got right that whenever you have evaluative feedback, meaning I don't know how to do this, but if you do it, I know when it works well. So I can judge better. There's a verifier generator gap. Right. There are problems where there's a massive verifier generator gap. Board games are a perfect example of it, but those are not the only games. Turns out, unit tests with code is also an example of it, and there are other cases that are also examples of it. Theorem proving with math, and I'm sure Carina will talk about it. Anytime you have that verifier generator gap, and you have a way of getting verifiable rewards. And crucially, what people forget is the reason why games were first is you have a perfect environment. And you have a simulator of that environment. You can run it, and you can do massive amounts of rollout. Those were the perfect settings for making that work. What did they get wrong? What did that community get wrong? not enough emphasis on broad understanding of the world and pre-training. And those are the two things that we're seeing in the combination of, multimodal LLMs and LLMs in general, combined with RL. It just sort of, I'm not trying to nitpick, but the most recent RL results, like DeepSeek for theorem proving and code proving, they're technically not RL, they're bandit problems because you're not dealing with an external environment. You're generating a token by yourself.
Right.
It's internal monologue.
Yep.
At some point you're done and you either get a reward or not, which means this has implications on both the algorithms, but also the systems that you guys create. You folks understand very well that if there's no external environment, then there's a certain kind of optimization. You are going to try to get max throughput through that one GPU. You're not bottlenecked by an external world. If I bring in a bash terminal or a text writer or a web browser as an environment that you have to go interact with, wait for response from that environment to perceive, then take the next step, suddenly your infra challenges become very different. You're now having to deal with the kinds of problems that gameplay agents did, where you have to run multiple environments in parallel and deal with variable length batching of the rollouts that you're having to do. So that's the world we find ourselves in now, where a bunch of companies and frontier labs are realizing that I just need extremely interesting environments that are high throughput, that I can parallelize, that give me rewards in the end, and I can construct infra around it to elicit capabilities. And where I start from is not from scratch, which is the mistake that the last batch of RL made.
Yeah.
But with those aside, it is a compelling framework. Coming back to the example that you started with, you give ChatGPT our names. I give, Scouts by Yutori a link to this event, and I said, go find me who the panelists are and tell me everything that you can about them. So the first, there's not enough information in there to execute the task. So the first, it has to go read that link to find who the panelists are, then conduct another search to learn about them, then maybe look them up on LinkedIn or other personal websites, then comprise this information. This is an environment loop that you have to take on, because anytime you deal with a world that is changing, maybe this link had not listed all the participants. You'd have to go monitor it again. You just have to take that head on, and RL lets you do that.
I'm kind of curious to get Carina's take here, because formal mathematics feels like an area where you can have a verifiable reward, right? There's a ground truth to how you actually solve or formally solve a theorem, for example, or back when we were building theorem, we had theorem proving team, which is now the Mistral team, largely out of Meta. We had environments like Lean, for example, and we were doing MCTS, and it was kind of a brute force approach, right? It's like an LLM plus MCTS, or Monte Carlo tree search. But how do you see mathematics? Is it playing here?
Yeah, 100%. I think I'm very excited about the future of applying RL in areas where there's really good grounding and verifier, just like math and code. I think it's very intriguing to think of. Because math, when we kind of think about it and we see the math data that's being fed into the large language model, it's doing formal reasoning in natural language. But if you use programming language like Lean 4, then you can suddenly attempt to turn the entire mathematical literature into GitHub actionable code and to apply all the amazing techniques and progress in the coding space to mathematics. If we think about kind of math and how it's different from, say, chess and Go, it is a very big action space. At each step, you can take many possible moves. And if you just apply the sort of techniques that we have seen that made amazing gains in coding to math, but you have a data scarcity problem. So, if you scrape all the Lean code on the internet, there's only about I think a couple million lines of code, which is not enough. And how to kind of convert these natural language math data into Lean code, I think that remains a stubborn technical challenge that we are super excited to try to solve at Axiom.
Oh, very cool. Where do you see so if you're able to And we still haven't solved like Riemann hypothesis through AI. That was like, if you recall, when we were putting our North Star goals together, back when we were in FAIR together,
Yep.
that was like an aspirational goal. I don't think we've solved that yet. No one solved it, AI. I guess how would you see, like, what would a breakthrough look like, I guess, in your space?
100%. I think there are really like 4 stages as we see it. One is kind of problem solving. We have seen a lot of mathematical benchmarks that are numerical answer graded. So if I get the answer right, then I score. If I don't, then, it's a 0. But the next stage will be theorem proving, where I want to make sure that the intermediate steps leading to the final solutions are correct and rigorous mathematical reasoning. We're not there yet. Large language models currently are generating a lot of proofs based on sort of pattern matching on what's, fed into the training data. We kind of have not seen it being able to reason we haven't been able to see it do grounded reasoning without hallucination on the intermediate steps. And then that's the second stage, which I call the rigorous stage. And there's a big leap to the third stage, which I would call conjecturing, which is having large language models propose interesting mathematical problems to try to solve. And these conjectures are it's so different from what it has seen before. And the fourth stage is kind of intuitions and theory building, connecting these dots, these new conjectures, problems, and the solutions into theory, into mathematical theories and frameworks, and put them into context. Like Grothendieck has this idea of if you put mathematical concepts in the right framework, then the solution might emerge like a landmass being swallowed by the rising sea. And that's a very beautiful mathematical idea and a very powerful one, but we have not seen the AI mathematician being able to do that, and that's what we're really excited to build toward.
Oh, very cool. I guess tangential to math in the biology space, because I have a biologist, a nouveau biologist.
A very new biologist.
Very new biologist.
I play biologist on panels, I guess.
You play. So, as you know, Sal is a former, CTO of the Loon project, which was balloons flying in the atmosphere, providing internet access.
Correct.
Right. Okay. So he works on crazy stuff.
Using reinforcement learning. So,
of course,
interact with
it's back.
It's how you get funding, right? It's RL. I guess, how has your role changed? I mean, when we were back in FAIR and we were training large language models, or, they were quote large language models, they were actually pretty small at the time. How has this kind of agentic world changed biology, changed how you guys approach? Has it changed? Or are you still just kind of is your roadmap, it all changed? Has it allowed you to raise more money, calling it an agentic biology startup?
Well, I mean, so the world has definitely changed, but I think it's just it's a big progression for AI for math and science, right? From where it was. So I think we've seen very large sums of money go into some of the big pre-training labs, right? Yep. In other companies. And I think that for AI for science, it's just a little bit behind on that same curve, but it feels like it's very much on the same trajectory. So, you think about maybe 5 years ago or something like that, we all of a sudden large language models happened, and we said we should train these things to write code, and then people started working on that, and now they're pretty good at writing code, right? And there's a huge amount of value coming out of that, right? Both in terms of economic value, but also just our time, right? You go and you are able to build things so much faster. And I think we're seeing the same thing, at evolutionary scale with the kind of the biology that we're working on. So I am not a biologist, I work with biologists, but I have no idea what was going on with some of these things, especially when I started. But I was able to do some actually the reason I got into evolutionary scale was I started working on protein design just because I was interested, and I was working with some colleagues on that. And, I was playing around with the models, and I was doing things which I thought, oh, this is cool, this is interesting, this is a nice little weekend project. And then I talked to people who I knew who were experts in the field, and they were like, you did what? Like, and like, I'm kind of an unremarkable person, so you kind of know it's like the models which are getting a lot better. And we just see that happening, right? Like, so how do I end up working on, going from something which is pre-training large language models on biological data to now working on like making drugs, right? Like, it's because like that curve of capabilities, like all the models are climbing up it. And so I do think that like, it's a little bit behind, but we're going to start seeing people have we are seeing people have great world results with these things, and it's going to come more and more to the focus of people's attention. And then I think, more investment will come in. I should say that like our investors put a lot of money into our company. So I think there's like I think there's a lot of people who are thinking this way, but it's the smart money that's doing it right now.
Yeah.
I'm curious because like I feel like it's so cool that you guys are doing. I would say that it's scientific superintelligence. How do you think about like working toward pretty kind of like general capabilities versus specialized like problem? Because in math we have trade-off between like good general performance on benchmarks that are getting harder and harder. I mean, they are currently at graduate or research level, but also it's a totally different question to, like work toward a specialized problem. Like, for example, you say the Millennium Prize problems.
Yep.
So is that the same sort of trade-off you see in AI for science? Like, is a model being able to do many, many things,
So I hear Donald Trump somewhere in the audience.
Yeah.
I really don't want to hear that voice right now. Go, Sal.
Yeah, I'm just gonna go. So yeah, I think that's a great question. So the way we kind of see it is I think there's two critical importance. Like, there's two critical things to building like a virtual scientist, right? Or even going beyond like what a scientist can be. So there are simulators, and like a lot of the models that we built, like our traditional models, like ESM models, are essentially simulators of biology. They're not like molecular dynamics or something like that, but it's a simulator built to an information bottleneck, right? Like, and it simulates like a protein or a genome. The other thing that's happening, right, like, and many in the field are building it, is reasoning models, right? Like, and when you fuse these two things together, you allow the reasoning model to reason not only in the space of words or whatever space it's, choosing to reason in, but also in the latent space of something that, sees the world through like amino acids or something like that. And I think that's a really interesting fusion. So we work at it from those angles to bring those two pieces together.
Cool.
It does feel, generally like the world is kind of going in a certain direction. The sciences will kind of like fast/slow follow depending on who you ask. I'm kind of curious though for Eugen though, like on this, you've worked at like a lot of different layers of the stack. And like we talked about agentic frameworks, there's obviously that we go all the way down to the metal where we're generating kernels, for models. Like where do you see the bottleneck in things, and where's the most innovation needed, I guess, in the stack?
Yeah, I would say still it's like trying to take these models and training them on like hundreds to thousands of GPUs. We've kind of seen over the past few years this trend, even in open source, towards like bigger models as we like try to close the gap with API models. Like Llama, for example, Llama 3 was like 70B for the medium model. Now Llama 4 is like 400B. Same trend is happening for Qwen. Same trend is happening for DeepSeek. And there are like libraries out there that kind of try to let you do this, like try to let you scale models, but sort of the kind of use cases they solve are very disparate. Like there's some libraries that are nice to use, but maybe don't support all parallelisms, so then you can't scale past a certain limit. There's other ones that maybe support everything, but don't support the architecture and like the sort of attention mechanisms you care about. There's other ones that are like way too complicated to use. You can't really iterate, like it's hard to understand. And now with RL, kind of like as Dhruv was talking about, like we see that in our kind of workflows as well. Like we're moving towards this world where we don't just have single chat models. We have these like agentic models that use tools. This adds like a new layer of complexity. Like how do you do generations well? Like how do you transfer like your huge model weights from your training GPUs to your inference GPUs efficiently and so on? And in that area especially, there's like nothing sort of, well, I shouldn't say nothing, but there are like very few sort of tools to use in open source. And at least for us, like because of all these issues, we've kind of had to build everything from scratch. And it's not a place that we necessarily want to be in. Like we're a pretty small post-training team. We'd love to just run experiments. But yeah, there just isn't anything like too great out there. And I think there's potentially an opportunity to kind of improve things.
That is a perfect segue to my last question for all of you. Lightning round. If you could have anything from PyTorch, or I guess if you want Llama, that's fine too. But if you could have anything from PyTorch, what would you want? Like your deepest, wish, whatever you could have. Maybe I'll start with Horace over here.
I think my requests are like pretty different from most other people's requests are.
It's okay.
I think my requests are mostly at like the lowest level. So like things like kernel authoring, things like detensor, things like symmetric memory. Like I think when you're kind of at like a more like frontier type lab, it is kind of like you end up building like a lot of things yourself, or like, at the very least you're capable of building a lot of things yourself. And so a lot of the times the things that are useful are like the fundamental building blocks that are like reusable and are like solid that you can like reuse. And so those are kind of the things that.
Okay. We'll keep working with you guys on that for sure. Dhruv?
Here's what I want, and then I'll backtrack into what PyTorch can give. Every digital surface that a human interacts with, their phone, their app, their browser in their laptop, their email, their calendar, everything is a tool call for an AI system. It's just an external memory mechanism. It's a way of communicating. It's a way of dealing with the world. And I want every digital surface to just be
I got a roadmap now.
A tool call away in, high throughput, high bandwidth.
So essentially a library of incredibly high performance environments. I mean, believe it or not, actually, I'm already building something like that. So we'll talk later. Okay, awesome. Sal, what can I do for you, sir?
We also want to scale models. So actually, I knew you were going to ask this question, so I asked my engineering team on Slack.
Yeah.
And their answer was the same as mine, and similar to Horace's. Like we want better sharded checkpointing, detensor, all the level stuff. I mean, when we train out models, we kind of have the PyTorch layer, and then you have a layer of other libraries, and then we write our own stuff either on the top or on the bottom or whatever. And the more of that stuff we can kind of get rid of and just have like PyTorch and what we want to customize, the better for us.
Okay. Eugen?
Yeah, for us, pretty similar, honestly. Like we want to be able to scale models, and I know PyTorch has been doing a lot of like awesome work here around different scalability methods, and like we're pretty excited about that. I guess more on the model side, like we would love a better tool calling model. At least like on the chat side, there are open source models out there that kind of close the gap with API models, but for tool calling, like the Quen, DeepSeek, like they're okay, but they're not like as good, and like having something better there would be amazing for us.
Cool.
Yeah, we would love to see just like plug and play, like to do RL at scale, like TorchTune. I know that like there are some like really amazing recent updates. It's getting kind of more and more keeping up with the state of the art, like algorithms that's rolling out. It's quite interesting. Now we think about GRPO. It actually came from DeepSeek math. It's like these algorithms, we would like to kind of be able to have them available in TorchTune. That's
awesome. Yeah, I don't know if you caught, it was very subtle in Aparna's keynote this morning, but the little butterflies in there. So if you kind of like look for Monarch and PyTorch, you might see, Horace knows, maybe not everyone else knows, but yeah, you can imagine kind of like a God mode, being able to scale. I think Eugen would be right up his alley. Cause like, I think we're just like fundamentally running out of ways to like aggregate enough power and GPUs in one place. And so if you can do this like across data centers and actually like literally scale up to like that level, which I think is like, insane. It could be inference, could be post-training, could be, obviously pre-training, but make it feel like you're kind of writing code locally and feel like natural, like you're sitting here on your Mac, like, developing PyTorch locally. Like that's kind of like our objective. So, yeah, it's really cool. Anyways. Awesome. I think we're out of time. How about a round of applause for our panel? Thank you. Awesome. Thank you so much. This was a wonderful conversation. Yeah, I appreciate all the answers. Really diverse panel and so many different perspectives. Thank you again. I appreciate it. Cheers.
Thank you.